Alright, welcome to Contemporary Math. Today's lesson is on 13.7, normal distributions. So a normal distribution is actually a frequency distribution. Where the mean, the median, and the mode all have the same value. And what this tells us is that the data is evenly distributed around the mean. Now, since it's a frequency distribution, we can make a histogram of it, and the histogram actually looks like a bell curve. And this curve is symmetrical. Okay, so you have a nice picture of a bell curve right here. And this would be the histogram of a normal distribution. This line right here represents the mean, the median, and the mode. So all three of these values would be the same, and they would be right here in the center. And because it's symmetrical, we know that this side over here on the left is going to be the same as the side on the right here. Now, when we talk about normal distributions, we need to talk about z-scores. Now, a z-score is a number, and it's the number of standard deviations a piece of data is away from the mean. Okay, so last lesson we talked about standard deviations, and that's really how far the data is spread out from the mean. And so each piece of data will have a z-score, and the z-score is going to be how many of those standard deviations is that piece of data away from the mean. So to find it, okay, we can let all our pieces of data equal x. And so we say the z-score for a particular piece of data, x, is going to be that piece of data, x, minus the mean. Okay, we can write mu or x bar, and then divided by the standard deviation, which is going to be s or sigma right here. Okay, and really what we're writing here, to do this, we're going to take the data, piece of data, minus the mean, divided by standard deviation. So this formula will give you the z-score for any piece of data. Now, what we're interested in is the area under the curve. So what we say is the area under the curve equals 1. And that's the total area. Now the area under the curve always corresponds to the percent of data that falls between any two values. So when we think the total area under the curve is 1, that really stands for 100% of the data. Okay, so every piece of data will fall under this curve. Now the area is given in a table here. So the area given in table is between the mean and absolute value of a z-score. Okay, so again, this is what it looks like. We have our normal distribution. We have our mean. And we have a z-score. And that's the area given in the table. Now notice it says absolute value because if we have a negative z-score, it'll just be on the other side, and it's the same as the area for a positive z-score. So now we're going to practice shading some of these areas and then giving their percentages. So in our first example, it says shade the area under the curve that is less than the mean and give its percent. So if we look at this, we have our normal distribution, nice bell curve. On the bottom here, we have the z-scores already listed for us. So notice 0 is right in the middle. It goes positive 1, 2, 3, 4, and then negative 1, 2, 3, 4. So less than the mean. So what I want to do is draw a line at the mean. And if we want to shade everything less than the mean, now we're shading on this side right here. Okay. So if we think about this, and we know this curve is symmetrical, the same on the left as on the right, and the total area under the curve is 1, this actually gives me half of the data. So the area is going to be 0.5. So what does this mean? That means half the data which is 50%, is below the mean. Now in our next example, it says shade the area under the curve within 1 standard deviation of the mean on either side and give its percent. So within 1 standard deviation could be to the right or to the left. So here's 1 standard deviation above the mean, and here's 1 standard deviation below the mean. Okay, and I'll just draw the mean in here. It's a good habit to get into. So here's what we're looking for. And it turns out that this area ends up being 0.68. I'll show you how to find this in just a second. So if this area equals 0.68, what does that mean? Well, 68% of the data is within 1 standard deviation of the mean. So as we think about standard deviation being the spread or variability of the data, if we know what that standard deviation is, we can tell how much data actually falls between the mean and those standard deviations. So that accounts for 68%. Now our next one is going to be within 2 standard deviations. So now you can see here we're getting quite a bit more of the data. Okay, it's quite a larger area right here. We're just doing the most common ones here. Okay, so we're looking for this area right here, and here's our mean. And it turns out the area under this is about 0.95. So what does this mean? 95% of the data is within 2 standard deviations of the mean. So as that spread increases now to 2 standard deviation, we have about 95% of the data there. Now let's move on. Our next one is going to be within 3 standard deviations of the mean. And you can see here we're almost getting all of the data now. Here's our mean. All right, and this is about 0.99 area. And what does this mean? 99% of the data is within 3 standard deviations of the mean. So in our next examples, we're going to be looking at finding z-scores. Now remember, z-score is the number of standard deviations away from the mean. So given a population is normally distributed with a mean of 50 and a standard deviation of 10, find the z-scores for the following pieces of data. So when we think about this, x equals 70 and the mean was 50. So 70 is bigger than 50. Our z-score has to be positive. So what we want to do here is find the z-score for 70. So we just write z of 70. Now what this is, it's the piece of data minus the mean divided by the standard deviation. So here we get 20 over 10. So this is 2. So 70 has a z-score of 2. And it would fall right here on the normal distribution. Now x equals 50. So we can use our formula again. Z of 50 equals the piece of data 50 minus the mean divided by the standard deviation. Now here you can see we get 0 over 10. So the z-score of 50 is 0. Now that makes sense because if the mean is 50, the piece of data 50 is 0 standard deviations away from the mean because it is the mean. All right. piece of data now is 20. Let's find its z-score. So z of 20 equals the piece of data minus the mean over the standard deviation. Now here we get negative 30 over 10, which is negative 3. Now, looking at these, if we have a positive standard deviation, pause. Now looking at these, if our z-score is positive, that means our piece of data is bigger than the mean. If our z-score is 0, that means our piece of data is the mean. And if our z-score is negative, that means the piece of data is smaller than the mean. So looking at 65, is this going to have a positive or a negative z-score? Well, 65 is bigger than 50, so I'm expecting a positive z-score. So let's see here. Z of 65 equals 65 minus 50 over 10. We get 15 over 10, which is 1.5. And we did expect a positive, and we got it there. This also shows you that your z-scores don't have to be even numbers or whole numbers. They can be decimals as well. Alright, so on the first page I gave you the percent of data between several very common values within 1 standard deviation, 2 standard deviations, and 3 standard deviations of the mean. But you can actually find the percent of data between any 2 values. So, very important, number 1, the first step is to sketch the diagram. And then you also want to make sure that you label everything and shade what you're looking for. That's going to be extremely important whether you use the Z table or your calculator. The sketch is going to help you determine logically what you need to find. Now number 2, by hand, you want to find the z-scores. Okay, remember that's x minus x bar over your standard deviation. Number 3, you want to find the areas that correspond with the z-scores. So you're going to use that table. And you find areas that correspond to your z-scores. Okay, and that's going to be for each z-score in the problem. And then number 4, you're going to use the examples below to find the total area. And of course, the corresponding percentage. Okay, so the next couple things we're going to be doing here are looking at general circumstances. And we're going to be using some logic and some general areas to determine how to find them. So the first example is just between the mean and a z-score. Okay, so the mean is right here, and we can label that as a z-score of 0. And we'll just pick any z-score out here. Now in this example, we really only have one piece of data. Okay, so here's the area we're looking for. Okay, so notice this is z sub 1, so it's our first z-score, and here's a sub 1, the area that corresponds to that z-score. Now in this case, all you have to do is look it up in the table and find it. Now our next one is between a negative and a positive z-score. Okay, so again, here's the mean, which is a z-score of 0. So a negative z-score will be over here. We'll just call this z sub 1. Okay. And here is its area. And I'll label this a sub 1. And then we'll also have another z-score. That'll be positive. And the area from the table will be over here. Call this a sub 2, corresponding with our second one. So if I want to find the total area here between a negative and a positive z-score, I'm going to add the two areas. Another example you might see is between two negative z-scores. So now we have a z-score here and another negative z-score here. Let's name them z sub 1 and z sub 2. So when you look for the areas, z sub 1 will actually give you an area from here to here. I'm not going to shade it in because we're not looking for that area. Notice we're looking for this area between the two z-scores. Okay, so your first z-score gives you this area from here to here. We'll call this a sub 1. Then your second z-score will give you this area. Now notice it always goes to the mean here. So from the mean to the z-score, this gives you area 2. So notice how these overlap right here. So if we want to find just this piece right here, we're going to have to subtract the two areas. So just go a sub 2 minus a sub 1. That'll give you the area you're looking for. Now between two positive z-scores, kind of gives us the same situation. So here's our mean, and both our z-scores are on the same side of the mean. In this case, they're both positive. And here's the area we're looking for. Now z sub 1 is going to give you the area from the mean to the z-score. And the second one is going to be right here. Let's call that a sub 2. So if we just want the shaded area in here, we're actually going to take a sub 2 minus a sub 1. So again, it's that idea that our two areas are overlapping. So if we just want this part, We're going to subtract the two areas. All right. Our next example is involving only one z-score now. And this is greater than a positive z-score. So here is 0 at our mean. And let's just say we have a positive z-score. And we want to find the percent of data that's greater than that value. So now we're looking for this little tail out here. So when you find in the table the area, remember you're finding it from the mean to the z-score. But that's not what we want. We want out here. So we have to think back to the fact that the area from the mean all the way to the right is actually 0.5, or half of the data. So if we want to find just this tail out here, in this situation we're going to do 0.5 minus a sub 1. Now in a similar example, if we want less than a negative z-score, here's our 0, here's our negative z-score. And if we want less than, now we're talking this tail right out here. So again, we want to find our area for our z-score, but that gives me between 0 and our z-score. And we use the fact that everything to the left of the mean is 0.5. So taking 0.5 and subtracting area 1, we're getting the area we're looking for. So it's 0.5 minus a sub 1. So in both these cases, if you're looking for just the little tail, okay, you're going to go 0.5 minus the area found in the table. Now the next example is greater than a negative z-score. So here's our negative z-score. Here's our mean. And if we want greater than, notice we're going to shade everything to the right. Now in this case, when we look up our z-score in our table, it's giving us this area from the mean to the z-score. There's a sub 1. But we have to include all of this other area, and the area from here to the right is 0.5. So in this case, when you're looking for this entire tail, so the big one, we're going to add the two areas together. So it's going to be a sub 1 plus 0.5. In our next example, it's similar. So now we're less than a positive z-score. So here's a positive z-score. Here's our mean. And we want less than, so it's everything to the left. Now when we look up our area in our table, it gives us between the mean and the z-score. And you guessed it, everything to the left is 0.5. So if we want our total area under the curve, again, we take the area, A1, plus 0.5. So these are all your possible scenarios. So that's why it's very important to sketch the diagram in the first place, so that you can match it up with whatever you need if you have trouble knowing whether to subtract or add along the way. So now let's give a couple of these a try. It says sketch a drawing and find the specified area or percent of data. So the first one is between the mean and a z of 1.3. So we're just going to sketch a normal distribution here. Don't worry if your pictures aren't all that great right now. We just want to be able to get the general idea. So we Draw our curve. We put our mean in. We're going to put 0 right there. Now 1.3 is going to be to the right of the mean. It doesn't even matter where you put it. Just make sure it's to the right. Then we're going to shade the area we are looking for. So now what we want to do is find the area that corresponds with our z. And to do that, we're going to look in this chart right here. We need to find z of 1.3. So if we look here, we're going to find it right there. Now it's kind of funny here, the area is actually on the right side. So here's z of 1.3 has an area of 0.403. So go ahead and just find that area. And now we're going to analyze kind of what's going on here. Now remember, our table gives us the area from the mean to the z-score, which is 0.403. And in this case, we don't have to do anything extra. So the percent of data here is actually 40.3%. Letter B. Here, it's between z equals negative 0.56 and 1.21. So we'll draw our basic sketch here. We'll put our mean right here at 0. Now we have a negative 1, so that's off to the left. And then we have a positive z-score. It's off to the right. Shade in what we're looking for. Now again, when we find our areas, it's always from the mean to the z-score. So let's look at z of negative 0.56. Now negative 0.56, we want to look at positive 0.56. And you can see it gives us an area of 0.212. We're just going to record that in here. Okay, so our first area is 0.212. And now we want to find our second area. It's from the mean to the z-score. I'm going to look up 1.21. You can see it's right here. Z of 1.21 gives an area of 0.387. I think this is the easiest example to find, and you can probably see what's going to happen. But looking at our last chart that we just did, you want to compare your sketch here. You can see that this sketch and this sketch is the same. So it's between a negative and a positive z-score. So all we have to do here is add our two areas together. So the overall area going to be 0.212 plus 0.387, which is 0.599, and then we just change it to a percent. 59.9%. All right, moving on. Next we have between z equals 1.63 and z equals 2.47. So let's draw our sketch. Now in this case, both of them are positive, so they're both going to be to the right of the mean. So we'll just say 1.63 is here, and 2.47 is here. And we are looking for this area right there. So we're going to look up in our table for our first area. So 1.63 gives us an area of 0.449. You can draw it right there, or you can just write it off to the side. And now we're going to look for our second area. Okay, so z-score of 2.47 has an area of 0.493. I think it's a little bit easier just to write it off to the side there, or you could write it right on top of this. Now in this case, if we look at our charts here, this is between two positive z-scores. And so when we have this sort of overlapping area on one side, we subtract the two. You don't have to worry too much, just subtract, do the bigger one minus the smaller one. Okay, we get 0.044, which is 4.4%. We're going to jump down to below 1.86. So we're going to draw our curve. And our mean. 1.86 is above the mean. And we want below this. Usually when there's two sections on either side of the mean, I shade it like that. Now we look up our area for the one z-score that we have. So 1.86. Actually up here. It's an area of 0.469. Now, because we're looking for all of this area, we know that this is 0.5. And again, you can always return to this sheet right here and match it up with the right sketch. So this sketch is the same as less than a positive z-score. You can see what we have here is our area plus 0.5. So that's just what we're going to do. 0.469 plus 0.5. And we get 0.969, which is 96.9%. All right, and we're going to move down again. Well, we're not going to move down. We're going to move across to F. So here we want above Z of 2.72. So here's our mean of 0. 2.72 is positive. We're going to draw it off to the right. And we want above this. So we're going to shade everything to the right, and we get this little tail. Next, we look in our charts for the area. So we find z of 2.72, and 2.72 is right here. It's an area of 0.497. It's from here to here. Now again, if we want to match this up with our chart, this one, to me, looks like this one. So greater than a positive z-score. Looks just like this. So we do need the 0.5 from here. It looks like we're going to subtract our area. And this gives me 0.003. And when we convert this to a percent, we move the decimal 2 to the right. We actually have 0.3% of the data. All right. I want you now to go ahead and finish up D, G, and H. We'll come back together in a few minutes, check your answers, and then I'm going to show you how you can use the calculator to find all these. So go ahead and take a look at your answers for D, G, and H. Let's see how you did. For D, you should have gotten 26.5%. For G, 64.4%. And H, 12.5%. Now we're going to see how we can use our calculators to help us out with this. So here is a slide showing you how to use the TI-84 to find the area under a normal distribution. So first, you want to hit enter. So first, you enter second dister, and now you want to choose normal CDF. Now for today, all we're doing is dealing with using z-scores. So we're looking at the green there. And it enters normal CDF. And what you want to do is enter your first z-score on the left, and then your second z-score on the right. So z sub 1 is the smaller or lower z-score, and z2 is your upper z-score. Now if you need to use the extremes like the tails, when we say to the left or to the right, go ahead and just use 5 or negative 5 depending on whether you need the higher or the lower. So let me show you how some of these work. Okay, so you're going to hit second dister, and we want to choose normal CDF, so it's the second one here. Now, for example A, our two z-scores are 0 and 1.3. So we enter the smaller one first, and then the larger one second. We hit enter, and notice it verifies our answer. Let's try it for B. Okay. So again, second dister, normal CDF. Our lower z-score is negative 0.56, comma. Our upper z-score is 1.21. And it verifies our answer of 0.599. Okay, let's check another one. Okay. Now here, we're going between 1.63 and 2.47. So second dister, normal CDF, 1.63, comma, 2.47. Gives us 0.044, and there's our 4.4%. Notice the rounding might be off a little bit. We could write 4.5%. Let's try our next one. Okay, you can see shading is still going to be very important so that we can tell what we're looking for. So here, second dister, normal CDF. We have negative 1.55, comma, negative 0.45. Sure enough, 265, 265. If you do use your calculator, it's okay to round up. Now for our next one, we have to trick the calculator a little bit because we're not going between two z-scores, we're just going to the left of one z-score. So in this case, when we hit second dister, normal CDF, what we're going to use on the left is we're just going to pick something way to the left. So something that's very far. And so we're just going to use negative 5. And that's going to pretty much account for everything. So just hit negative 5, and then comma, 1.86. And here you get 9.69, or 0.969, which verifies what we got. So in this example right here, we're going to go between 2.72 and something way far to the right. We can just use 5, and that's going to be far enough. So second dister, normal CDF, 2.72, comma 5. You can see 0.003, 0.003. Go ahead and try the next two on your own and verify that this works here. So there you go. That's how we use the calculator to find the area or percent between two z-scores.